Thank you everybody for coming, taking the time to be at the presentation. My name is Vicente Romero. I work for Oracle, and today we'll be talking about Project Amber, what's new about Java with the faster release model, and what are our plans for the future of Java. So this is general disclaimer that we show in all of our presentations. So a little bit about myself. I'm a compiler engineer. I work for Oracle since 2012. I started working with lambda in the project. It was pretty hard starting doing that, no? And of course also fixing a lot of bugs and the normal stuff you do when you start and join a big team, no? Still working on bugs and more recently working most of the time on the Amber project, on new features, and in particular these are the two features I'm working on right now: records and seal types, which are part of Project Amber and which we'll be talking about in the presentation. So as we all know, now Java has moved from a from a feature-driven release model to a time-bound release model. So in the past, we had a number of features hitting a particular release, and until we had all the feature complete, we wouldn't go for the release. No, that happened with 8 when we were working with Lambda. That happened in 9 when we were working with Jigsaw, and we have moved to a more agile and faster release model in which every 6 months we have a release. Everything that is ready go into the release. If something is not ready for that release, then it waits another 6 months. And that doesn't mean that those features going, let's say, in this faster release cadence are less finished, even though we have made much of them preview features. The reason we have preview features is because we want feedback from people actually using it in their code. So for them to test it and check how it works, what doesn't work for them, and give us feedback. But as I was saying, the feature is fully specified, fully implemented, and even with IDE support. So in particular, going already into Project Amber. Project Amber is about adapting to rising developer expectations, reducing language ceremony, and modernizing the language. No? So we want, let's say, to add productive tools to the language, to make it faster, to develop code, to make it faster to find bugs, to make it faster to read the code and make sure that you understand, for example, other person code, etc. So it's been a common complaint that Java requires too much ceremony to develop anything, and so that you have to write more code in Java compared to other language to get to the same goal, no? And we want to make that one of our main goals. To reduce that kind of ceremony for things that are not necessary. Mostly because we don't want places for bugs to hide. So if you can read the code and get a sense of what's happening faster, and you can understand it, you don't need to spend too much time and you reduce the opportunities for cutting and pasting code because let's say, for example, when there is repetition, there is opportunities for bugs to move from one place of the code to the next. No? So what is within Project Amber? So we shipped local variable type inference in 10. We shipped expression switch in 12. Text blocks in 13. Records in 14. A first phase of pattern matching in 14.2, and we have others in the pipeline, which are seal types and pattern matching phase 2. So talking about local variable type inference, it was I was saying introduced in 10, and what it does is that it improves the potential for type inference in the language. So instead of writing the first block of code, which has the type information, the variable, and the initializer, you can just remove the type information and write and use the type name var, and the compiler will infer the type information for you. In most cases, it will be what you were expecting it to be. In some cases, it could be a different type, so that's something you have to be worried about. But of course, it improves code readability and makes the development faster. So, as I was saying, even though the type is inferred, it doesn't mean that Java is not statically typed anymore. There is always a type attached to the variable, and so basically, the two code samples above are exactly the same. No? I mean, are equivalent. So, what are the places where we can use var? var is intended for implementation, basically. So everything that is inside a method that is not public, you can use var for that. You can't use it for fields, method parameters, or return types, because those get written into the class file and gets to be part of the API of the class. No? So whatever is internal to the class, you can use var for that. Whatever is local, whatever is public or part of the API, you can't use var for it. It could be a problem if the compiler infers a different type from one version of your program to the next. No? So that's why we don't allow it var for public API. So var doesn't imply finality. If immutability is a problem, is a concern for you, you should add final. And another restriction or another thing you have to be worried about is that you have to add an initializer after the variable name. So immediately after the variable, you should provide an initializer. So another feature we been working on in Amber is switch enhancements. And the things that we realized that a significant fraction of switch statements are real expressions. So a lot of programmers use a switch statement to actually simulate an expression. So we have, for example, the following code. This is just an example in which we are assigning a value to the same variable in every arm of the switch. And at the end of the execution of the switch, the result is that the variable has a value assigned to it. So that's simulating an expression. So with expression switch, we can now do this now, which is a lot more concise. It is more easy to read this code to find if there is a bug here or no. And it has basically the most important information. There is no break. There is no, also check the new form of case where we have several cases in one go, and we also borrow the arrow syntax from lambda to make more explicit that this is the value we are returning. You can still add a block if you want, if what you're doing is more complex. And see also that you don't have to add a default. If all the cases are covered, the compiler will understand that there is no need for a default case. So summarizing what's new for Switch, we have 2 orthogonal enhancements to the expression. To the Switch expression. You can use it as an statement as an expression, and if you go for the expression form, it must be exhaustive, and we have streamlined the case clauses, making it easier to add several cases in one go. And still, if you want to use the expression version, then you have only one consequence. But you can add a block if what you're doing is more complex than just one consequence. And it plays very well with pattern matching, as we will see later in a bit. So another feature that people have liked a lot is text blocks. So we know that we need a lot of code from other languages or just string literals that could come from JSON, SQL, HTML, and you have to manually break the string in order to keep, let's say, the syntax from the external language. That's time-consuming. That can lead to bugs. And it's something that we have to do a lot. And for example, if you are doing HTML programming, you use it a lot. And so we got to the concept of a text block. So we defined a text block to be a 2-dimensional string literal, which can split to, we can span to multiple lines. And there is an indentation that comes with the probably sometimes the particular language. So this is what we have to write right now to simulate what a text block is, and this is what we can write with text blocks now, starting in version 13. So not a big thing, but it saves a lot of time. And there is an indentation that is somehow implicitly here. No? So everything starting from the HTML is not incidental. It's something that you want the compiler to preserve. So let's say that the gray points, it's incidental indentation. You don't want the compiler to include that into your string. So what you really care about is this block of text. No? So you want the compiler, and that's what we did, to remove every incidental indentation and just, let's say, get the condensated content of your text block into the string literal. This is something that's been pretty popular between Java developers. So going on, records. Records come from the many uses that data classes have. So think, for example, a class point, a class person. No? So you have to define, for every data class, you have to define the constructor, the toString, the hash code, the equals, the accessors. If you forget to add any of them, then it could be that if you use it in a hash map or whatever, then it won't work because you forgot to add the hash code method, or you added a new field and you didn't consider it into the hash code method or the equals. So it's a place where bugs can hide very easily. And doesn't support changes very well. So we want to write this, a class point with two components, int x and y, but we have to write all of this. So we have to provide all of this additional code that doesn't add anything to the common understanding of what a data class is, no? But we have to do it in order to have a correct class. So with records, we can now write this. So we are just stating that we have a record point with two components, and the API of the record is declared in its components. So there is no need to add toString, hash, equals, constructors. If all what you want is a point that contains two components, that's all you have to declare, and that's enough. No? So it gives us boilerplate reduction, but it's not only about boilerplate. It's about making the components the API of your data class. It allows the compiler to infer the methods you have written yourself, and it saves, I would say, a lot of time and a lot of pain for developers. So still record are classes. So if you want a record point, and you want to add a method that calculates the distance, you can do it. I mean, it's a class. You can add whatever method you want to. You probably also want to add a constructor, because you probably want to check if, for example, you have a range. If you want to check if the low point is smaller than the high, no, and you want to throw an exception if that doesn't happen. But somehow, if we were to do this, no, we are not reusing the information we already have. I mean, because see that in the constructor, I'm repeating the same information I already have in the record declaration, which are the parameters. I mean, the record components. I mean, shouldn't the compiler already know that I will be having a constructor with two ints, low and high? So we have defined the concept of a compact constructor, in which whatever is in gray is not necessary. So you only need to declare public, branch, and write the body, and there you can write your checking code. If you want, for example, to normalize the arguments before assigning them to the fields, the rest is generated by the compiler. Also, records support annotations and type annotations, so you can attach an annotation to a record component without having to declare the explicit method you want to, or record member you want to apply the annotation to. For example, let's say you want to apply an annotation to the accessor of the method. You don't have to go down and declare the accessor and declare the annotation and attach it to it. You can attach the annotation to the record component, and depending on the target, it will be propagated down to the right member. So, for example, if you write an annotation that is applicable to a parameter, the annotation will be propagated down to the parameter of the constructor of the record, and so on. So there are a lot of use cases for records. Suppose, for example, we have two methods: one to find the minimum of a list of elements, and another to find the maximum. If we had records before, we would have declared something like this. So a result that contains both of the values you care about, and then you only have to invoke the method once. No, of course we can do this right now with Java, but then you have to write a more complex data class to just hold two values. Another use case could be with streams. Suppose, for example, you want to process a stream of data, and there is a property you want to calculate. So that could be done with two arrays, probably with a lot more code. But check in this case that the record is local to the method. There is something here that is very interesting, even though it could seem simple. Records are static always. So we are declaring a static member inside of a method. And we allow that only for records so far in the language. So you can't declare an enum inside of a method, but you can declare a record inside of a method. And this is a wildcard for records. And it could be very useful for cases like this, when you want to do something internal that you don't want the user to see what you are, what data classes you are using to support your implementation. So there are a lot more use cases for records. There are three nodes, data transfer objects, compound map keys, whatever. I mean, there could be a lot. And we see, for example, the transition as we see it is that people will probably start using records inside of the implementation, like local records. And with time, they should probably start using them in public APIs too. Sorry, in the API too. So seal types is, we hope, for 15. And seal types play very well with records. Records are somehow product types. No? So a product type because the space, the state space of a record is the product of its components. And some seal types are another algebraic type, which are sum types. No? And in a sum type, you say, okay, I have this concept, which can be this, or this, and nothing else. No? So it's like dividing a set into classes. And so let's suppose, for example, that we define that a shape could be a circle or a rectangle and nothing else. Defining a seal type with these concepts allows the compiler to infer about exhaustiveness. If you use the seal type in a switch, for example, and so the seal type is declaring and enforcing what subtypes it can have. So you can declare another subtype that is not listed as subtype of a particular seal type. And seal types also play well with records. Why? Because records are final by default. So a record can implement an interface. So in this case, we have even less, more reduced code when we play with the relation between seal types and records. So seal types are a generalization of finality. It allows libraries to suppose after the data types, but still control implementations. And this is something that is very valuable for platform libraries. So before you only have final, you could only say, okay, this class is final, you can't stand it. But now if you need your hierarchy to be a little bit more complex, seal types can help on that. So now going into pattern matching. So we've seen that sometimes a lot of the code we write when we use instance of is, okay, is this object an instance of this class? Then you cast to that class, of course. That's what you wanted to do, and then you extract the information and you do something with it. No, and there is a lot of repetition here. No, so you repeat the type twice. This is error prone. This is irritating, and this somehow hides exactly what you really want to do. No, and so the solution for this was pattern matching. I mean, what we did to fix this problem. So in 14 we released pattern matching instance of. So we write, in the case we have here, we have an if statement, and before we were only saying is object instance of integer. So now we are adding a variable name, and if the object is instance of integer, then that variable name will be bind to the value, and then you can use that variable going on inside of the if and do something with it. No, and we are working on other types of pattern matching, but instance of was the first, and I would say is probably was the one that people were wanting the most, and they work very well with shortcutting. So, for example, in a lot of cases we have the equal methods. The equal method is mostly this object instance of my same class, and it happens to have this and this property the same. So if we have pattern matching, I mean, now that we have pattern matching, we can do this kind of stuff now, and which leads to simpler code, faster to understand, and faster to and better to maintain. No? So this is what we have to do right now. When we are trying to assess the type of an object, and then we have to write a lot of if conditions and do the casting and all the conversions that we know that a lot of methods start with, no. But once we have pattern matching in Switch, which is something we are working on right now, we'll be able to write this kind of code and see the difference. I mean, it's pretty obvious what we want to do here. Exactly, you write only what is important for your application, and if we combine this with expression switch, the code gets even more reduced and more readable. Also, on a later phase, we'll be working on the construction patterns, nested patterns, and more. So, for example, the construction patterns, suppose you have a record, which is circle, and you want not only to check if shape is an instance of circle, you also want to create fresh variables, which are center and radius, to do something with it after if the condition is met. No? So here you have the construction pattern, and in just one line you can write something that before needed a lot of code. So the constructor is just the opposite of a constructor. We're working on that, and records in a next phase we probably have them by default. So it will be easier to connect and use records with pattern matching and leading to better code. Also, pattern matching works well with seal types. You can infer that if you have covered all the subtypes of a seal type, then you don't have to add another case, no, because you already have circle and rectangle in your switch, and the compiler then doesn't force you to write a default. I think I went faster than I expected. In my hotel room, it was closer to the hour. So, in summary, Project Amber covers a pretty broad range, but we are still in the same theme of making Java code readable, easier to understand, reliable, and as error-free as possible. We are addressing some long-standing pain points, and we have a lot of features. Not all of them are too complicated, but there is a lot of interaction between them, making the sum of the parts bigger than each part in separation. And we have focused on the semantics, and as a result, the boilerplate has been reduced a lot. And so we plan to continue evolving the Java language. I've been talking only about Amber here, but we have other projects. We have Valhalla, we have Panama, we have Loom that we're also working on. And so that's it. Thank you very much. I don't know if anybody has questions. Thank you.
In the instance of if statements, wasn't there a kind of double casting system? Because constant instance of some integer, and that integer was further casted to int with an integer casting.
That's the example of what you have to do right now. Right now, yeah. Yeah, with the pattern matching, you won't have to write the.
But then in pattern matching, it went to switch statement. Are you including the if statements also?
The switch statement, yes. Yes, there will be a phase 2 of pattern matching in which we will also improve the connection, the interaction between pattern matching and switch statements. Yeah.
So how do you decide which features do you want to work on Project Amber? And is there a way to know what you're going to work with once pattern matching is done?
How we decide? That's a very good question. I would say it's a very complex process. In the past we've been doing surveys. We've been asking on Twitter, for example, to some developers, what do you guys see as the most important area where we should focus on? But also we check what other people are doing and what other features in other languages seem to be trendy and people like them. So we try to include them in the Java language. And because, for example, other languages already have tried with pattern matching, and we've seen the problems they have had, and we've seen also the reaction of developers. So that's now a big driving force. Yeah. And to be aware of what we are doing, well, we try to publish the JEPs and try to start a discussion. There is a list, Amber-dev, Amber-dev. You can subscribe to it, and then you can be, check what's happening. Yeah. I didn't get you, sorry.
So with records,
Uh-huh.
we get a lot of things with the vendors, right? I don't suppose we get builders also on that?
Builders, you mean with, using a with, for example. So the question is if records will include builders at some point. Yeah. We've been considering that. Yes. But we hope that, that's something, yeah. Yeah, exactly, yeah. That's something it's not there yet, but we've been considering working on that, yeah. Yes?
Are there any plans for value types?
Value types?
Types that when the data isn't always locked.
So the question is, are there any plans for value types? Yes, but that's part of Project Valhalla. Yeah, and probably records will interact a lot with value types, and we are still defining how that interaction will be. Huh?
It's not clear to me how records are used. Are they generating their own class files? You can use them by a format.
So how records, the question is how records are compiled. Records can be in the same Java file than other classes, so you don't need to declare a record per Java, per source, let's say. I mean, for every class, there will be a class file. Yeah. So what happens is that during compilation, the compiler will generate the methods and members that you didn't have to write because you knew the compiler will generate it for you. No, exactly. It's a class. The only difference is that records can extend another class. That's let's say, the only limitation for records.
Do you have an example of what the syntax might look like for writing a constructor?
No, I don't have any. We are working on that, but no, I don't have any. But it would be very similar to the syntax of a constructor. So the idea is that for records, the compiler will generate the constructor, which will be what you will have written. But if the class is not a record, then you have to write the constructor yourself. So because in the case of the record, we have enough information to generate the constructor because we have the record components. And we know that there is a match between the record component and a field internally in the record. But we don't have that kind of guidance if it is a general class. So in the case of a general class, you will have to write it. Yeah.
About records, so I wasn't aware of the local records,
Mm-hmm.
which is fun because it removes the tricks with an administrator class that you put in your lambda to return fields. How do you work with the JVM team so that thing is not actually an instantiated records and it could be just like an unstacked replacement thing that won't allocate anything?
So the question is how local static records works with the JVM. Well, actually for the JVM there is no impact. They don't care much about if a class is static or no. The limitation was more in the compiler. So what we did was remove a couple of checks here and there and allow them to be compiled. And given that the record doesn't extend any class, you have all the state there. So you don't have any dependency with other fields or other instance of an external class or a class that contains the record. So that's good. All the information is there. And that's why it has to work so well, I would say, yeah. Yeah.
And about seal type, why do we think it's important?
Well, seal types, the idea of seal types is to have an enhanced finality. So instead of when you have a class and you declare it as final, it can't have any subtype. If you declare it as a seal type, then you have a little bit more control on what your subtypes can be. This could be important for API developers. Of course, you probably don't need it for all the applications you write, but it could be used for some applications. Also, you can infer. Sorry, if you write a switch statement on the seal type and you have added cases for all the possible subtypes, then you don't have to the compiler doesn't force you to add a default method. I mean, it's not the size of lambda, but it adds another flavor to the language, I would say. Yeah.
Probably you must have said that already, but if a record is in a method, which is like a local, it's still static, right?
Yes.
But then how does a compiler see it? Because then it will see a class inside a method, which is kind of weird for a compiler to see it like that, right?
Well, right now you can declare a local class inside of a method.
No, I can declare local class inside.
Yeah, you can have it now. The problem,
Static?
not static. Not static, but it is a class. The only thing is that it's not static. The difference is now with the records, it is static.
Okay. So compiler sees it as static class.
Yes, yes, and this deals with it as a static class. Yes.
Okay.
Yeah. Any other questions? Well, I mean, I'm very glad because we have had a lot of very interesting questions and a lot of them. Cool. Thank you very much.